Hello kids, today we are going to start with real numbers, exercise 1.3. So as you know, a number is called a rational number if it cannot be written in the form of p by q. P by q, a rational number is represented in this form where this q is not equals to 0 as division by 0 is not possible. So a rational number can be represented in its form, but a rational number cannot be represented in this form. Example of few of the rational number is root 2, root 3, root 15, pi. Pi is also a rational number, and a non-terminating decimal which is not repeating, not terminating is a rational number. So a rational number, again I'm just saying that it is a number which can be represented in the form of p by q, where q is not equals to 0, and p and q are integers. Now there is another theorem in this exercise which is saying that you have a prime number, p is a prime number, let us say 2. If 2 divides any number, suppose say 2 is dividing a number 6 square, 2 is dividing 6 square, or I can say 6 square is divided by 2, or 2 is a factor of 6 square, so then I can say that 2 also divides 6. So this is what this theorem is saying. So let p be a prime number. If p divides a square, that means that p divides a also, where a is a positive integer. Any positive integer you can take. So another theorem, now you have to prove that root 2 is irrational. So this theorem, what I just told you, will be used over in proving this thing. So let's start the proof of this. So this proof, we will start with an assumption. Whatever is given, that you have to prove that root 2 is irrational. So you will say that let root 2 is rational. Now as root 2 is rational, you can write it in the form of a by b. So you can say that this implies that root 2 is in the form of a by b, where a and b are co-prime numbers. Co-prime numbers. What is the meaning of co-prime numbers? That their HCF, their highest common factor is 1, meaning they do not have any common factor. So let's cross multiply it. So root 2b is equals to a. Now squaring both the sides. When I square both the sides, I'll get root 2b whole square is equals to a square. From here I can say 2b square is equals to a square. This represents that 2 divides a square. This represents that 2 divides a square. So by that theorem I can say that 2 also divides a. I can say that 2 divides a. So let us say, so I'll go over here, let a equals to 2c. Let us say a equals to 2c, some another number. So if a equals to 2c, what is a square? A square will be equals to 4c square. So this is my equation 1. This is my equation 2. So put 2 in 1. So when I do that, what will I get? 2b square is equals to 4c square. This shows that b square is equals to 4 by 2c square, meaning this is also equals to 2c square. Now this implies that 2 divides b square. This also implies that 2 divides b. Now from both these things I am getting that 2 is a common factor of a and b, as it is dividing both of them. But this contradicts the fact that a and b are co-prime numbers. So what will I say? That our assumption was incorrect. is incorrect. Therefore, root 2 is irrational. So I hope it is clear. So what you have to do is, let's start from the beginning. You will assume that root 2 is a rational number. So it can be represented in the form of a by b, where a and b are co-prime numbers, meaning their HCF is 1. Now let's cross multiply. Root 2 into b is a. Squaring both the sides, you will get root 2b whole square equals to a square. So 2b square is equals to a square. Now this shows that 2 divides a square. If 2 divides a square, that means it divides a also. Now let us assume that a is 2c. So a square is equals to 4c square. Again I squared the both sides. Now put this value of a square as 4c square in this equation 1. You will get 2b square is equals to 4c square. This shows that b square is equals to 2c square, and hence 2 divides b square, and hence 2 divides b. Now a and b both have 2 as the common factor, which contradicts the fact that a and b are co-prime numbers that we assumed in the beginning. Hence our assumption is incorrect, so root 2 is irrational. Now let's come to another example. So I'll just shift it over here and we'll start with the next question. Now here we need to show that 5 minus root 3 is irrational. Again we will start with the same step. Let 5 minus root 3 is rational. Now if 5 minus root 3 is rational, so again I can represent it in the form of a by b, where again a and b are co-prime numbers. A and b are co-prime numbers. So let's take root 3 on one side and other numbers on another side. So 5 minus a by b is equals to root 3. So when I solve it, I will get 5b minus a by b is equals to root 3. Now as all this 5a minus b by b is a rational number, so they all are rational numbers. As a, b are integers, so 5b minus a by b is a rational number. This becomes a rational number. So when this is a rational number, so root 3 is also rational. But as root 2 is rational, we have already proved, so root 3 is also a rational number. So we can do it like that. But this contradicts the fact that root 3 is irrational. So our assumption is wrong, and hence I can say that 5 minus root 3 is irrational. So hope this is clear. Let's move to next example. This is the exercise, so let us just shift it below because we have to finish that part also. So let's start with this. Again we will say that let 3 root 2 is rational. Now if 3 root 2 is rational, so again I will write it as that 3 root 2, I can represent it in the form of a by b, where a by b, a and b are co-prime positive integers. The same way I'll do it this example also. What will I do? I'll take it root 2 on one side and it will become a by 3b. Now this implies that root 2 is rational. Why? Because a by 3b is rational, as A and B are integers. Same statement, but this contradicts the fact that root 2 is irrational. So hence 3 root 2 is irrational. Hope from these examples it is clear how to do these questions. Now we will be doing these questions also, which are there in the exercise 1.3. So let's start with the first question. So first question says that we need to prove again that root 2 is irrational. So let me take this part, I'll copy it below. First we'll do this question. So let us start with the proper step once again. So let root 5 is rational. So if root 5 is rational, so you can say root 5 is in the form of a by b, where a, b are co-prime positive integers. So b root 5 is equals to a squaring both sides. What will I get when I square both the sides? I'll get b square 5 is equals to a square. This implies that 5 divides a square. This implies that 5 divides a. Okay. Now let a is equals to, I'll take it as 5c. Here I'll take it as 5c. So what will be a square? A square will be equals to 25c square. Now let this be equation 1, this be equation 2, and I'll go over there. Put equation 2 in 1. So what you will get as 5b square is equals to 25c square. So here I can say b square is equals to 5c square. Meaning here this implies that 5 divides b square, which implies that 5 divides b. This contradicts the assumption that a and b are co-prime numbers, because I'm getting 5 as a common factor. Okay, as 5 is the common factor for a and b. Okay, so hence root 5 is irrational. Done. Now let's do second question. Just cut this one. This is the second question. So let's do this first, then we'll go to the third question. So second question, again let's start here. You will take that root 5 is irrational. So let, because that should be given to you, 3 plus 2 root 5 is rational. We will start in this way. So therefore 3 plus 2 root 5 is equals to a by b. Now let's take the variables over there, one side, and we'll take root term on another side. So this minus 3, when I'll take LCM, it will become as b a minus 3b root 5 2, and this 2 also will come over this side. It will be a minus 3b by 2b. Now this shows that root 5 is rational. Why this shows that root 5 is rational? As a, b are integers, therefore a minus 3b by 2b is rational. If this is rational, so what is equals to that is also rational. Here I have to say that A, B are positive co-prime integers. But this contradicts the bus. This contradicts the fact that root 5 is irrational. So therefore our assumption is incorrect. And 3 plus 2 root 5 is irrational. I hope till here it is clear to you all. Now we have the last question of the exercise. Again, these are the same steps, so let's do only one part, and I think rest of the part you all can try on your own. So let's do the A part. You have to prove 1 by root 2 as irrational. So again we'll start. Let 1 by root 2 is rational. When you assume it to be rational, so again you will say that therefore 1 by root 2 is equals to A by B, where A, B are positive co-prime numbers, or you can say instead of numbers, integers. Better to say that, not numbers. Now let's cross multiply again. So you will have B equals to root 2A, which will, on squaring both the sides, just a minute. On squaring both the sides, you will get B square is equals to 2A square. Now this implies that 2 divides B square. This also implies that 2 divides B. Now let us assume that B equals to 2C. So if B equals to 2C, B square will be equals to 4C square. So again this is equation 1, this is 2. Put 2 in equation 1. So what will I get when I put? I will get 4C square is equals to 2A square. So this cancels out, you'll get 2. So A square is equals to 2C square. This shows that, this implies that 2 divides A square, and also says that 2 divides A. 2 is dividing the square of a number, it will also divide the number also. So this contradicts the fact, this contradicts that A and B are co-prime. Contradicts that A and B are co-primes. So hence 1 by root 2 is irrational. So hope these type of problems, how to do step by step, is clear to you all. If any doubt, you can contact me. So try rest two parts on your own. They are all easy. We have done similar type of questions, so you can try them. So thanks for watching the video. Bye.